Afternoon everyone. Time for another refurbishment project. So a guy called Phoenix, who contacted me quite a long time ago, we had a lot of messages to and forth about his speakers and bits and pieces. Finally, it was me delaying things just with everything going on. Finally he came over and dropped them off. He dropped off these, which we'll talk about in a minute, his KEF cadenzas and his KEF 104s as well. So we're going to be refurbishing these and then look at the others afterwards. So this is a pair of PSB speakers. It's not a brand I've heard of before. I don't think they are particularly big in the UK. I think they're more America, sort of that sort of area, that neck of the woods, but yeah, I'm not familiar with them. So they're pretty big. Physically they are about 60 centimeters tall, so 2 foot, 25 centimeters wide, 10 inches, and 28 centimeters deep, 11 inches, and the covers are about 2 centimeters thick as well. Pretty heavy. Funnily enough, this one seems to be heavier than that one. I'm not too sure why that is. Yeah, finished in black ash vinyl, which is pretty. Yeah, so the cabinets are very nicked and damaged, and like I say, this is just a vinyl black oak effect. By the look of it, it's chipboard as well. So Phoenix has asked me to wrap these. These normally sit on his REL, I think they're T5i subwoofers, and they're in a gloss black. So we're going to probably end up wrapping these in gloss black, which works quite well. So yeah, let's have a look behind the grill. So there we go, two-way design. Covers are held on with these kind of bobble fixings that just push into the holes. That one's broken off. Unfortunately, we haven't got it, so we can't glue it back on. I might have something I can use on that. So yeah, thick chipboard frame. The edges are being rolled out, which is nice to see. Let's take the other one off as well. Okay, so the cloth on these, it's not bad. It will clean up. I don't know whether we're going to end up reclothing these. We might do. This one's okay actually. That will probably clean up quite well. This one is a bit bobbled. Often a bit of heat will shrink those back in. But yeah, not too bad really. So two-way design. We've got an 8-inch woofer in each. I'm assuming it's 8-inch. More like 7. Yeah. So big boxes for that size woofer. Ported design. Quite a long port. 6 inches, so 15 centimeters long. Probably about 50mm wide, 5 centimeters. So yeah, big box for that size woofer. Probably 3/4 inch. Yeah, 3/4 inch silk dome tweeter. And then on the back, these will take a wire or a banana plug in the back. So these are the PSB Century 500i's and made in Canada. So yeah, like I say, I don't know much about these. Serial numbers aren't consecutive, but they're not too dissimilar. This is 38, this one's 20, so not the type of speaker that would have come out of the factory as a match pair. But I've done the measurements and they have issues. They really do. So let's have a look. So in terms of their on-axis performance, it's pretty good really. They're quite sensitive, about 90 dB at 1 kilohertz. And me measuring from 300 hertz up to 20 kilohertz, they're probably from 300 to 10k, about plus minus 2.5 dB, and we do have a rising response right at the top. So I'll put the on-axis and phase measurements for each speaker up now. So as you may have seen from that, we do have a bit of a dip around 5k, and then I'll put up a comparison of the two now. And as you can see, they're matching up pretty well. Yeah, we do have that sort of 5k dip, which is a bit odd really. One of these has a lot of distortion in it, so I'll put up the distortion measurements now of this one here. And this one had a bit of distortion between 6 and 9 kilohertz, so right in the tweeter range. So I'll put that in now. And then the other had a load of distortion in the woofer, so I'm not too sure what's going on there. From 1000 hertz and down, full of noise, and when I was playing the test tones for the measurements, you could really hear that. So I don't really know what's going on there. And again, similar to the other, between 7k and 10k, there was a bit of distortion in the tweeter as well, so I'll put that measurement in now. So next, if we look at their vertical performance, so I'm measuring first of all on tweeter axis at a meter, and then going up 10 degrees again. We can kind of begin to tell where the crossover point is, and it's quite high up. So I'll put that measurement in now. So as you can see, at about 3.5 to 4 kilohertz, we at 10 degrees start to dip down, but at 20 degrees we are quite scooped out. So that kind of tells us where our crossover point is, where our time alignment changes as we go up, and we're developing that dip. Horizontally, as we go, so again starting 1 meter on tweeter axis, going horizontal across, at about 15 degrees we are still pretty similar to our on-axis measurement, which is good. But as we come nearer to 25-30 degrees, still pretty good. The time arrival doesn't change that much as you go horizontal compared to vertical, where the distance does begin to change between the drivers. We start losing output in our woofer, and that's because the woofer's beginning to beam. So as we move off, we are coming out of the range of the woofer. If you look at it or think of it as a torch, as you move out of the beam, it obviously becomes darker. So it's the same sort of thing. So that again points to this playing up quite high, as opposed to using the tweeter lower. So I'm expecting to see maybe a first order filter on our woofer, allowing it to play up quite high. I mean, this is quite a small tweeter, but it could probably play lower than it is. So I'll put that measurement in now. Yeah, and as you could probably see, 30 degrees off axis, our output is just pushed down. I did have a quick listen to these. I didn't spend much time listening to them. I could hear that distortion, and you'll get this with speakers anyway. Once you stand up and walk around in the room, go off axis, their tonal characteristics will change. These do quite a lot. So yeah, I think that was all the measurements I took. Yeah, okay, so we will take them apart and have a look inside, and then following on from that, probably in part 2, what I'll do is measure the drivers individually and then see what we can do to improve on things. It's not too bad. Pleasantly surprised, really. But yeah, let's take a look inside and see what we're dealing with. Oh, one last thing to note. The box feels pretty solid, but when you hit the top, there's this funny resonance inside. It's like it's something shuddering. So I don't know what that is. Okay, so before we have a look inside, I'll give you a bit of a close-up so you can have a better nose around them. Our port is a cardboard tube inside there. So as you can see, we got some nicks on this one. This one isn't too bad. So what we'll probably end up doing is flattening all this off before we wrap it. If we start taking this off, which we could do with some heat, we might start pulling the chipboard. So I think we'll tidy it up and go around it, over wrap it. So yeah, you can see here chipboard that's come out, so we'll have to repair that. I think that happened on the way here. Phoenix had to brake rapidly or hard and they went flying around in the car. But yeah, otherwise this one isn't too bad. Okay, let's take apart the one that had all that distortion in the woofer. Righty-ho. Let's take our woofer out first. So just wood screws. I always keep the lids of my spray cans and things when they're empty for that sort of thing. Right, what have we got here then? So plastic ring, just to trim these out, which is quite nice. Is this going to be easy to get out? Yep. Okay, so we have a gasket around our woofer, push fit connections, we don't like them. So there's our woofer, can you see that all right? Yep. Polypropylene cone, yeah, pretty nice. I can't see any reason why we would have distortion from the actual driver itself. Small magnet, stamped steel chassis. Yeah, nothing amazing, but nothing too bad either. Okay, so the chipboard on the baffle is pretty thick. It's probably a good inch. The reason why she's sounding solid is because there's a lot of bracing in here. So I'll bring you in for a closer look in a minute. Yeah, that's pretty good. Definitely a chipboard box. Teeny wood screws in the tweeter. Okay. So again, push fit connections. There we go. Small little magnet on that. Yep. Cardboard gasket. So this is a 6 ohm tweeter, and our woofer, there's nothing on it but possibly an 8 ohm. Yeah, okay, I will bring you in quickly to have a nose around in here. Yeah, so as you can see, a lot of bracing in there. This sound deadening, it's sort of stapled on there, it's coming away. That was flapping around, maybe that was hitting our woofer cone, I don't know. But yeah, there are improvements to be made there for sure. I would say the cabinet is dead enough, solid enough, but some better foam in there would certainly help. Looks like our crossover is on the back of the binding post cup, so we'll take that off next. La, 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 la. Yeah, nice cabinets actually, very solid. I like them. So it doesn't really say anything on the back here in terms of power handling, nominal impedance, that sort of thing. Oh dear. That's a bit naff, isn't it? Right, let's have a closer look at this crossover. Right, so here is our little crossover, and it looks like we've got an iron core inductor on our woofer, laminated iron core, which is a bit better than a big slug of iron in there. So first order on our woofer, that does explain the measurements we were getting. Then we got a 1 ohm resistor, so it looks like our tweeter circuit has this capacitor, an air core inductor. That electrolytic capacitor is about as naff as they get, and that is in the critical signal path, so in series with our tweeter. They've gone to the bother of using an air core inductor for the tweeter, which is in shunt, so making our second order, but the worst cap you can bleed and think of. So yeah, right, let's just draw this out to make sure we are about right. So this was our woofer cable. So if we look at our positive here, we pick up our inductor down there, come across to here, and yep, no other components, straight out to our woofer. So definitely first order on our woofer. There are unused solder blobs and holes, so perhaps this crossover board was used in other speakers, other versions, or there is a more complex crossover that can be added. But yeah, at the moment, we'll measure the value of that in a minute. We have an iron core inductor into the positive of our woofer circuit. Simple first order. Right, if we look at our tweeter, so we have our positive here, we come in, some point we're going to pick up our resistor. Nope. We're going through our capacitor first, which is just there. So we come in through a real crap capacitor, which is going to completely muddy and blur that sound. 4.7 microfarad. So in there, pick up that, and then from there we pick up our air core inductor. I assume that grounds. Nope, goes through our resistor first. So where are we there? Nope, it does go straight down to ground. So our tweeter. So what's our resistor doing? Here on this side. There. Right, sorry, our resistor is in there. 1 ohm. So yeah, that is it. Pretty straightforward, really. It always amazes me. The company have gone to the bother of making that really nice box. Okay, it's chipboard, but they've put lots of bracing inside it. Drivers don't look too bad. And then they wreck it all here. Laminated iron core inductor. The worst cap you can really fit directly in the critical path. When we're in shunt, it's not the end of the world. But they've used an air core inductor there. Why not use the air core inductor for the woofer? And this could be an iron core. Admittedly, that would be a larger value for the woofer, vice versa. And then spend another quid on a decent cap. And that resistor's probably pretty naff as well. Okay, let's measure these and see what we've got. Okay, so to measure our inductor, I can simply go between the positive of our woofer to the positive input. There is no other things in circuit there at all. So we can do that. Uh, 0.7 millihenry. That's a small value for a woofer. So that's the reason why our woofer is playing up so high. You know, really the crossover point is getting near 4 kilohertz, which is very high for a woofer that size, and explains the off-axis issues and stuff we've got. Yeah, ideally we'd like to pull that lower and maybe make it a second order, so it's not playing up as high. The roll-off isn't as gradual, it's steeper. Right, let's have a look at this inductor. So we should be able to test. We haven't got our tweeter in circuit anymore, so we can test from negative up to our cap there. And we won't get anything coming back yet. So we should be able to do it without desoldering it. So let's go to the negative input. And we want to find... Where are we? There. Yeah, sort of thing you'd expect to see. So 0.32 millihenry. And we can probably see how our capacitor's holding up as well. It's 4.7, but it's measuring 4.83. So, yeah, not too bad really. These are brass, but they've got steel nuts on them. Yeah, okay, so certainly improvements can be made to this from a component quality point of view. We could replace that with an air core, replace that with a decent polypropylene cap and that resistor, because that's in the signal path as well, with something decent. This iron core air core inductor is pretty good. Wiring soldered, it's copper, so these can be directly soldered to our driver. Better binding posts. Yeah, but I think we're going to try and get that crossover point lower. So to do that, I need to measure the drivers in the cabinet individually, just to see how really it comes down to how low this will play. Because at the moment this is playing up really high. Yeah, and go from there. So that'll be in the second part. And let's see what we can do with them. Right, later. One last thing, let's have a better look at these drivers. So yeah, polypropylene cone, fabric dust cap, yeah, stamped steel chassis. So what have we got on our voice coil? That's interesting. That meter doesn't like that at all. Normally I like to use that because you get the voice coil inductance as well, and that's a good thing to compare to the other. Well, that must be a 4 ohm driver, so 3.1 ohm. So I'll check the other one as well, make sure we've not got anything crazy going on there, because there was a ton of distortion in this one. And our tweeter. .4 ohm, so this is a 6 ohm nominal tweeter, so that's the sort of thing you'd expect to see. Right, I've just fished out the other woofer. Yeah, all looks good. So we're measuring 3 ohms on that one. And this one, yeah, the same. Okay, hopefully our issues are in that crossover. I wouldn't be too surprised. Anyway, catch you on the next one.